What's happening, people? Pastic here, and in this video, I'm going to show you some more calculus. By the end of this video, the goal is to hopefully come up with some meaning for this big old funky looking expression down here. So we're going to try and figure out what does it mean for the limit as x approaches a of f of x minus f of a over x minus a. What does that represent? And by now we've already kind of figured out that the limit as h approaches 0 of f of x plus h minus f of x over h, we've kind of figured out that that determines our derivativo of a function. So now we're getting a little more specific here with this difference quotient. And we're going to find out that there's actually a slightly different meaning for this one. So without further ado, let's do it. So on this page, you were asked to go back in your notes and fill in the derivative. So we're just going to do that real quick. So the derivative here was f prime of x equals 1 over 2 root x plus 2. And then over here, you're asked to plug that in. So I'm going to find f prime of 7. And that's going to be 1 over 2 root 9, which is 1 over 2 times 3, which is 1/6. Cool. So now in this box over here, we're going to attempt to apply this expression down here that I've already put in this red rectangular box here. This guy right here. We're going to apply this with this function using x approaching 7. So let's set it up. So we're going to do the limit as x approaches 7 of f of x minus f of a. So I'm going over here. F of x is root x plus 2. So f of x minus f of a. So f of x would be root x plus 2 minus f of a, and a here is 7. So 7 plus 2 over x minus a. So x minus 7. So we go ahead and simplify a little bit. We have the limit as x approaches 7 of root x plus 2 minus square root of 9 is 3 over x minus 7. And now you see a quotient. You see the radical up top of the quantity underneath. So hopefully it's triggering some brain cells to go ahead and multiply by the conjugate. That's what we're going to do. So root x plus 2 plus 3, root x plus 2 plus 3. And by now I'm assuming that y'all can simplify that and do that out. So I'm going to skip ahead and do that out, and I'll be right back. So as you can see, I've done this out. I basically just, I know that, it's quick at this point. You do this times this, you get x plus 2. You do negative 3 times 3, you get negative 9. And then that's kind of like the F and the L for FOIL, the first and the last. If you do the two inside ones, you're going to have negative 3 root x plus 2 and positive 3 root x plus 2. So you have that outside and the inside are going to cancel. So this is what we're left with. And now we've got the limit as x approaches 7 of x minus 7 over x minus 7 times the quantity root x plus 2 plus 3. And we know here that the x minus 7s will cancel out, giving us the limit as x approaches 7 of 1 over, all that good stuff, root x plus 2 plus 3. And then we plug in 7 and we get 1 over, looks like 1 over the square root of 9 plus 3, so 3 plus 3, which is 1/6. So you're going to notice that we just achieved the same answer here for this big old difference quotient as we did in the middle when we simply evaluated the derivative at 7. So what did we just find out? We just found out that this big expression, the limit as x approaches a, of f of x minus f of a, which is what we just did, but in more specific terms with this function, right, is equal to f prime of a. It's equal to the derivative of valued at a specific location. whatever location that value of A is. So what does this all mean? So we know now that the limit as h approaches 0 of f of x plus h minus f of x over h, we know that that's equal to the derivative of the function. We hopefully are kind of figuring out that the derivative of the function is going to essentially give us the opportunity to find the slope of the tangent line at any given point for the entire original function. So what is f prime of A? F prime of A, very specifically, is the slope of the tangent line to the curve of f of x at x equals a. So this expression, when you see this part right here, you got to know what they're asking you to do is essentially find the derivative and plug in the value of A. It's going to save you a lot of time. I do not want to have to do this. I don't want to have to do this every single time that I see this right here. Okay, eventually we're going to learn a quicker way to find derivatives. And we need to know that these two things are exactly the same. The difference quotient, the limit as x approaches a of f of x minus f of a over x minus a, is the same thing as finding the derivative and plugging in that value for a. Okay? We are going to waste a ton of time on the AP exam, on our quizzes, on our tests, as if we're doing this big thing up here the whole time. So right now, yeah, that's how we're going to do it, because we don't know the quick way to find derivatives, but eventually we will find the quick way to have our derivatives magically appear on our papers, and it's going to be beautiful. So that's it for now. Catch you all next time. Hopefully you learned something. Take it easy.